Before the presentation, I would like to introduce myself. I'm currently a professor in the Department of Mining Engineering at Hacettepe University. I received a PhD degree in geostatistics in 1993 from the University of Leeds, England. I have more than 30 years experience in academic research, teaching and consulting to industry. My research interests include geostatistical modeling and estimation in mineral resource applications. Outline of the presentation will include definitions of mineral resource and ore reserve, actually not ore reserve, only mineral resource. Then I will describe mineral resource estimation process, explain basic steps in mineral resource in detail. The stages include database construction, geological interpretation and modeling, block modeling and grade estimation, and finally, resource modeling. Now the definitions. Mineral resource is occurrence of solid material on Earth's crust in such form, quality, and quantity that there are reasonable prospects for eventual economic extraction. This definition shows us mineral resources have some properties. These properties are size, geometry, quantity, quality, geology, continuity, and prospects for economic extraction. Mineral resource estimation is an estimation of these properties from geological, mining, and other data information. Estimation of the first six properties can be reduced to estimation of volume, grade, and density. Mineral resource estimation is not only estimation of grade and tonnage, but also determining modifying factors such as mining, mineral processing, environmental and economic factors. At this stage, these factors can be determined from industry practice, for example, from similar projects. Ore reserve is a part of mineral resource that is technically and economically recoverable. Economic recoverability is determined by pre-feasibility or feasibility studies. Modifying factors consist of mining, mineral processing, geotechnique, hydrogeology, environmental, infrastructure, marketing, economic, social, and legal factors. Ore reserve estimation is a part of pre-feasibility or feasibility study. Grade tonnage estimation is not involved during the reserve estimation. Grade tonnage estimation belongs to the resource estimation. Modifying factors in the stage of ore reserve estimation are determined by detailed engineering studies specific to mine site. This figure presents classification of mineral resources and ore reserve. Mineral resource is classified into three categories, from inferred category to the measured category. Geological knowledge and confidence increases. Inferred resource category is inferred from limited geological knowledge and data. Indicated resource is estimated enough confidence to apply modifying factors. Measured resource category is estimated in such confidence that modifying factors can be applied in detail. Ore reserve is classified into two categories, probable and proven reserve. Mineral resources are converted into ore reserve by applying modifying factors. However, inferred resource category cannot be converted in or reserved because confidence in inferred estimations is so low to apply modifying factors. Mineral resource estimation process consists of database construction, geological solid modeling, block modeling, and grade estimation, and finally determining a reasonable prospect of economic extraction. That database construction starts with collection and assessment of primary and secondary data. At the end of this stage, resource database is obtained. In geological modeling, we interpret geological variables such as lithology, alteration, mineralogy, and structure in 3D. At the end of this stage, we produce 3D geological model. 3D geological model is a geometrical representation of the mineralization. In this representation, we never know the grade values. Therefore, we divide geological model into equal size and shape blocks and estimate mean grade of each block during block modeling. In this stage, we also classify estimated blocks based on the confidence of the estimates. At the end of this stage, we produce 3D block model. The final stage of mineral resource estimation is determining reasonable prospect for economic extraction. After that, we produce a resource model. Resource estimation process requires a teamwork. In this team, there must be geological and geophysical engineers, geostatisticians, mining and mineral engineers, environmental engineers, and people coming from economic, legal, and social disciplines. There must be some interaction between disciplines. For example, geological engineer must share his findings with mining engineers. Mining engineers share his findings with environmental engineers. This process is also a dynamic process. As the new data is obtained, all these models must be updated. Now basic steps in mineral resource estimation. Database construction. In the database, you have to have geological data such as lithology, mineralization, alteration, structure. All these are geological variables. In addition to geological data, you can have geophysical data, geochemical data, drill hole data, sample assays, density and rock quality information. All these knowledge and data are produced under quality assurance and quality control. In addition to geological data, we collect several data and information related to mining, mineral processing, economic, social, and environmental factors, because mineral resource estimation, mineral resources has reasonable prospects for eventual economic extraction. After validating the data that we obtain, we normally visualize it. Now I want to show you some drill holes made in a coal deposit. In this figure, different colors corresponds to different lithologies. This figure is the visualization of drill holes open in a coal deposit. Again, different colors belong to the different lithologies. At the stage of geological interpretation and modeling, we interpret the geology, mineralogical zones, structural geometry and alteration in 3D, and we produce a 3D geological solid model. This figure shows the geological solid model in the coal deposit. As you can see from this figure, there are 4 coal blocks separated by 3 faults. And this is the geological model made in the gold deposit. Again, different colors shows different domains. For example, in this figure, green color domain shows the low-grade zone. Yellow one, mixed grade zone. We have also high-grade zone, but it is not seen in this figure. It is in the mixed grade zone. Mineral resource must have reasonable prospects, as I explained earlier. Therefore, we must determine parameters for mining mineral processing methods based on geotechnical processes, grade control, metallurgical, and economical variables. Factors affecting the project economics, such as metal prices, cost, can be determined from general accepted industrial rule and practice at this stage. You must clearly state the assumptions for mining methods, slopes, selective mining, minimum mining width, dilution and production rate. You must determine cutoff value based on long-term prices, processing recovery, cost of mining, and mineral processing. Yes. During the mineral resource estimation, you must determine the cutoff grades. Cutoff grade is a function of long-term metal prices, processing recovery, and mining and mineral processing costs. Before estimating the block values, you must analyze the data. This includes calculating summary statistics such as mean, variance, minimum, and maximum values. Domains are homogeneous geological zones that show similar characteristics in grade. You must determine such domains in mineral deposit because estimation methods such as kriging and other estimation methods work in these domains. You must detect outlier values in the data set. Outlier values are the values that are significantly different than background values. In addition to the detection of outlier values, you need to determine how you treat these outlier values in the grade estimation. Because they affect the estimates significantly, outlier values. For this purpose, you can use some methods called capping and cutting techniques. Compositing is also important because estimation techniques use grade values defined on equal interval samples. If the sample interval changes from one sample to another, then you must composite them into equal length intervals. Variograms are one of the main tools of geostatistical analysis. Variogram function measures the spatial variability of a set of values, and we use the variogram function in kriging estimation. Construction of 3D block model is based on location, size, and geometry of mineralization zones, and also expected mining method and type and size of equipment. This figure shows the block model in the coal deposit. Block sizes are 50 meter by 50 meter by 2.5 meter. 50 meter is the lateral size of the blocks. 2.5 meter is the size in the vertical direction. This figure shows the block model for the gold deposit. Block sizes are this time are 10 meter by 10 meter by 10 meter. Now we must choose the estimation method. There are plenty of them. Polygonal one is inverse distance technique, Kriging, and geostatistical simulation are the methods that you can use during mineral resource estimation. The factors are deposit geology, grade distribution, and presence of high-grade values. During estimation, you must determine an estimation plan with search parameters such as the size of search ellipsoid, number of minimum and maximum samples in search ellipsoid, and number of passes as well. And this figure presents calorifical value estimates of the blocks in the coal deposit. Estimation method is Kriging. Coal quality is the variable, and coal block at the left-hand side has the very low quality, as you can see from the legend given in the figure. This figure shows the gold grade estimates of blocks in the gold deposit. Estimation method is the Kriging. Dark blue color shows low grade estimates, red high grades, pink unestimated blocks. We couldn't estimate some of the blocks because of data shortages. Block model is constructed under several assumptions and approximations. Therefore, we must test block model against the composite values. This table includes comparison of mean values of block model and composite. For consistent block model, these two average values, the average values of block model and composite, must be close to each other. How close it is, this inequality indicates it. You must determine some other test. For example, you have to compare block model with composite values on plan and sections. You also need to construct SWOT plots. These are the plots for directional means, and this figure shows the SWOT plots for the coal deposit. Each point in the plot is calculated from the means of block and composite values falling inside the slides. For example, in the upper plot, coal deposit is divided into slices with 50 meter thickness, and average values of blocks and composite falling inside this slice is calculated. These averages are later plotted against the depth. Same calculations are also made in east-west and north-south direction. For consistent block models, these curves must be close to each other. If the significant differences are observed, then these observations must be explained. After the estimating block values, you must move resource classification steps. Degree of geological and grade continuity, confidence in estimates applied to modifying factors are the main criteria during classification. This figure shows mineral resource classification in the gold deposit. Blocks in measured category are shown in yellow, blocks in indicated category in blue, blocks in inferred category shown in gray color. Blocks that are not estimated are not classified, and they are shown in pink. Grade tonnage curves are a graphical representation of tonnages and mean grade depending on cutoff and block size. Cutoff grade presents economic aspects of mineral resource, while block size corresponds to technical aspect. Figure on the top shows calorifical value tonnage curve, while figure on the right is the grade tonnage curve for gold deposit. As you can see from these figures, when the cutoff grade increases, tonnage decreases and mean grade increases. Mineral resource has reasonable prospects for eventual economic extraction. Therefore, resource model is produced by applying modifying factors to the block model. Factors during this stage considered are cutoff grade, mining and minerals processing cost, method, cost, processing recovery, and metal price. This figure shows the resource model for the coal mine. Extraction of this yellow coal block is found not uneconomic due to its low calorifical value. Therefore, it is not included in the resource model. In this figure, two vertical lines show the shafts, as you can see. Galleries are driven from the shafts to the coal seam. Yellow color lines show the longwall panels that will be used. These panels will be used for coal extraction. Some part of coal is left as pillar. These sections of coal seam are not produced. Therefore, this part of coal will not be included in the resource model. This figure shows the resource model in the gold deposit that will be excavated by open pit method. Open pit limits are determined based on mining and mineral processing cost, processing recovery, gold price, and slope angle. Resource model consists of blocks falling inside these limits, brown color limits. Resource at this state, do not forget that resource model does not include economic analysis such as calculation of net present value or internal rate of return. So net present value and internal rate of return are the measures for the project feasibility. During mineral resource estimation, these values, these parameters are not calculated. In conclusion, I should say that mineral resource estimation based on accurate, precise, and correct sample information. If you do not have any sample information, you cannot estimate mineral resource. To estimate mineral resources, you have to expert on this subject. Mineral resource estimation must be carried out by competent persons, and do not forget mineral resource estimations are for investors who want to make right decisions. That's all I want to say, I want to talk about, and thank you very much for listening to me. Oops.
Thank you very much for